Welcome back to this Copper on Drone series. So far, what have we seen? Right. First, we set up the hardware, so the embedded computer and the camera, and then we actually set up the cross-compiling environment, so we can actually compile Rust on our local machine and deploy on our remote machine, so we don't have to develop on the very small Raspberry Pi-like computer. And finally, we generated like a Copper project, and we've seen that it was working well. Like we had a source, we had like a task and a sync, and they were talking one another pretty easily. The end goal, right, is still to have those kind of drones be able to localize themselves with those type of tags, and kind of keep their position, right? That's going to be our first like simple iteration. What I want to be able to do is just put that on the wall and ask Copper to just follow the April tag and keep the drone at a constant distance, like from it. So if we change the tag, it would follow. So the next stage. Now that we have a project on Copper that works from sync to source, from source to sync, we need to get images in Copper, right? And what we will use for that is GStreamer. We could use video for Linux directly. We also have this support in Copper, but the thing is, I discovered this little hardware as only exposes their video for Linux as a multi-plane output, even if there is only one plane, which is completely stupid. But the fact is, like the video for Linux support for Copper, for Rust, sorry, doesn't support multi-plane very easily right now. And I think that GStreamer, if we use GStreamer right now, it will open up for us like a little bit more flexibility, because you'll see, right, we will be able to add like video elements along the pipeline, and GStreamer has a large support for that. So it will add a little bit more complexity into cross-compiling. We'll see that, but at the end, that's going to be easier for us to actually experiment and translate sources and so on. So let's get to it, and let's first add to our project. So this is the project as we left it last time. This is barely like just the generated code, right? We just add like in the binary folder like some scripts to be able to cross-compile. So first, what we need to do is to add to cargo.toml the dependency that will allow us to use the -GStreamer source from Copper. So that's how you add an external task type in Copper. You just add, it's a normal dependency in Rust. So let's go for this. So let's edit our dependencies, and here let's add -GStreamer. Yeah, you guessed right. And we'll take the latest version from the web, the one we published. All right, now let's see first if it does compile. So first locally. So that's gonna compile for the local machine. So it looks like it's going well. But now, if I want to compile it for the remote machine, there is a catch, and I'll show you that with the little script I built last time. So last time we only had that part, right? So basically, you recognize this one. Okay, let's enter it. This one, right? So normally, if you have only Rust dependencies, this is all you need, right? That's going to build for the target, and we set that up in our previous episode. But now, because we have GStreamer, we need to compile against the target GStreamer, not the local one. The .so and so on might not be the same version, not even the same architecture than the remote one. So what we have to do is basically copy, that's what I did there, right? Copy the remote environment into our project. So we are sure that we have all the supporting, for example, package config and so on files. So Rust can know, oh, okay, you are cross-compiling, but GStreamer, I can pick it up from this one. Those files are like when I do the copy, right? I just like rsync basically from the machine to the local desktop, from the remote machine to the local desktop. I put the entire /usr/lib into my own project. You could be like a little bit more surgical, but with rsync, the first time around is going to be really long. It's going to copy like, I don't know, a gigabyte or so of files. But after that, it's going to be super quick. And then it will only make differences. So you won't have to actually, you won't have to copy anything, right? And the advantage of rsync is that if you do like a oopsies, I forgot like one package, you can always do an apt-get install on your remote machine, and then that's going to be like next time you compile, it's going to be taken into account exactly as if you were compiling remotely, right? And you need to set that up. Those two like variables need to reflect from where you want pkg config to take their files, right? And okay, let's write my my little hack here. So you'll see it does its cross compilation really quickly, rsync very quickly because I just did it, and then it compiled pretty well. If you want to be sure, you can always do cargo clean and redo it. And again, the rsync part is quick, and then it compiles for the remote environment. And if it doesn't work, it will tell you exactly what to do, and you will see those like environment variables like pop up in the error, right? If you don't set them up, it says, you know what, you need to set those two variables to your remote environment, and those are you've seen it like /user/lib and /user/include. Those are those both that needs to be included in the build. All right, so we do have GStreamer now cross compiling. Now let's check. Let's check one last time because it's a little bit wonky. You will see. You need to run it like, I don't know, a couple of times to be sure that the pipeline is actually started up. I think the driver is a little bit wonky, or it doesn't. It has like some asynchronous like initialization. So let's go and try something that is close to the GStreamer's pipeline we want to use in Copper. So let me show you what I did. Oh. So what I'm doing there, we've seen that like the GST launch last time. That's a command line that allows you to start a GStreamer pipeline straight from the command line without any programmatic environment, which is pretty cool. So you can try that out before you copy paste this thing or part of this thing and put that in Copper, which is nice, right? You can experiment like a little bit like Python with the interpreter before you actually make a script. So what I do there is I take the video one. You remember we need to take this one as the source, and I did like I tweaked that a little bit. So there are controls that you can see with like a v4ctl dash device dash all. You can see basically, or dash L, sorry, dash capital L. You can see which controls you have, And by default, the exposure and the gain are too low on this ISP or this like setup. So every time I basically ask the video for Linux GStreamer element to reset that to the correct values. So tweak it like your environments, depending on your lighting and so on, and your frame rate might differ, but you need to do that. Let me put that so you can see it. I just want to capture one buffer, so num-buffer 1, so it stops right away. And what I ask the source is basically the NV12 format. So I talked about it a little bit before, right? That's the one I'm targeting because it separates the intensity, like the luma part of the image from the chroma part, the colors of the image. So you'll see, we'll use that as a trick to actually just get the contrast, because to get those targets, you don't need color, right? You just need black and white, and then you'll see we'll need to do like some filtering to be able to have a good contrast on them. So that's why I'm using that there. Then that won't be in the final pipeline for Copper, but what I want to do is just extract, like just convert it to a ping and then write that to the disk. So let's see if it works. Okay, you saw the first time it didn't, and now it works. So it needs to warm up a little bit, which is not really an issue when we will have video, because that's going to start like continuously, and maybe the first couple images will be ignored, and then it's going to start. That's my hope. At least we'll see a little bit later. Okay, so now I have I have this output.ping. Looks like it has something. Let's copy it. Here we go, and let's see if we can find it somewhere. There locally on the disk. Hey, look at that. So I have my other drone on the desk out there. So looks okay. It's green. It's normal. I always try to put like at least one green, one red, one blue, but at least we have the yellow. So it looks like it's fine. All right, so a little jump cut. Yeah, I spent like almost an afternoon trying to cross-compile GStreamer. It was really hard, even like importing like the entire environment from the little machine. So what I decided to do is, okay, for now, just for this episode, and I'll try to figure it out for the next one, is to just like use like a remote environment, and if it is too slow, I will just jump cut when it is too long to compile. So yeah, let's try it then. So we said that yeah, we expect basically a print per image. Okay, we have an error there. So it first tells us that basically GStreamer didn't give it an image, and then oh yeah, then we force, yeah, I know what happens. Then we force basically, and yeah, you see, we force an unwrap. So we don't take into account that yeah, if GStreamer keeps on running and not giving you an image, yeah, we need to be able to actually handle that case, right? So let's do that there. Let's say if okay, let's say payload equal input dot payload if payload to give me like some type of autocomplete, that would be nice. So I think this is none. We will just wait. All right, so now we should have a print for every single image. buffer with no timestamp that actually increased. That's interesting. Let's see what it says. So yeah, definitely, yeah, that actually worked. All right, so let's see. Let's see if we can send that to a rerun. So basically, we want to be able to show it, right? So if you look at the example in GStreamer, we are doing that actually. So let's get that up. Let's see. So in tests and GStreamer tester. So in the example in the new, we do a spawn, but we cannot really spawn. We need to be able to connect that to we need to connect that to our own machine, right? So let's check. Is it? Yeah, that's my machine. So my local IP. Sure, it is. Yeah, it's 81. Okay. So let's see what's the API for rerun. I think it's connect TCP opt, something like that. TCP opt. Okay, I'm trying to find where is it. Okay, maybe I'll start my local instance there, right? So I can look it up right away. So actually I was at the right spot. So GStreamer tester here. If I go there, so my local so it's connect with the address, right? So connect TCP ops. Okay, connect underscore TCP underscore ops. Connect TCP ops. Now pop-up is a little bit persistent. Yeah. So let's see this, and it needs. Okay, it needs a socket address. We have an example there. Connects up. ResDK default, no. So I'll try to create one. And that should be, I'm not sure. Okay, there is no from a string or something. It's really it's kind of awful. Okay, I guess I'll create it like that. I don't want to spend too much time on it. There's probably a better way, but it's okay. And what did we say? We said this one, right? All right. So I'm building here the thing to copy paste because the remote environment was not working in the others. It was absolutely so slow. So I do that like kind of locally, and then we'll see. Let's run rerun first, like locally. And it tells you, right? All right. So yeah, there was like a little typo. It was not message. It was input in our generated code, and yeah. So it took like forever to actually build. So let's try it out. I have here the where is my interface? I used to have. Yeah, here we go. Used to have rerun. Let's see if we run it, if the stream goes there. And so it's in target debug draw. So this is the next day, and I've been fighting that for like a few hours, and it looks like when I moved the little platform on my workbench. The workbench is like kind of a silicone coating, right? And it really isolates the chips, and it was overheating basically on the bench. I was like so confused. It was working once and sometimes not, right? So just redid that. That just put like a fan on it, right? And that's it. I just reinstalled the system because I was kind of desperate, but I realized that it was just like a physical issue. So now we should be able to make it work. Let's do debug. Sorry about that. Here we go. It's still a little bit wonky. So you see it's a bit laggy too, right? Like you see the images that are a bit like displayed later because there are a lot of like logging going on. So, but we have the basic runnings now, right? We have a source with GStreamer. We can get those buffers. We actually cut those buffers and we ship them on the network. So we have the basic of the sensing side of things. The next stage will be to, and that we will see that in the next video, will be to actually go in and try to find those markers, right? Those markers I'm talking about. So yeah, thank you so much for watching. Sorry for the little like wonkiness on the hardware side. But yeah, we are progressing, and next stage is going to be interesting. We will start to get into like actual robotics algorithms instead of just like setting up stuff and be sure that the basic layers are working. But that's robotics. It's always like there are always like a bunch of things that are actually kind of not working or working, right? So thank you so much, and see you in the next episode.